Okay, and welcome everybody. This is the source control and version control work tutorial from Steve Purves. He's originally an electronic engineer with a background in signal processing and computer vision. He's been doing software stuff, building products and R&D for the last 20 odd years. And a lot of that was with various geophysical data, seismic well logs, also looking at data crunching and visualization and some machine learning-y type things. So in terms of source control, he's gone through, or version control in general, he's done a whole bunch of things. So RCS, CVS, Mercurial, and Git. He's working at curvenote now, which is looking at version control and collaboration for Jupyter notebooks, which looks pretty exciting. And today he's just going to be talking about, some of these thoughts and practices around version control for scientists. So yeah, I'm going to hand over to him to take us through this. As always, the discussion is in the Slack channel. If you're watching this live, that is #T21-Thurs-source control. And yeah, the video will be available afterwards. So if you're watching this in the future, hello future people. So take it away, Steve.
Thank you, Martin. Great. And thanks, everybody. Welcome to this tutorial. I'm just going to share my screen. And I will switch my video back on for the moment. Great. So welcome along. And today, the next 1.5 to 2 hours, I'm going to be taking us through a whole bunch of version control concepts, really focused on the idea of version control for scientists. And of course, because scientists aren't software engineers, we're slightly different in our background, and also different in the amount of time we've got to pick up and learn tools like Git, for example. But if we do learn them and sort of adopt them in our workflows, we can start doing, we can start working in a way which is much more reproducible. It helps us collaborate and can also just give us a lot more confidence when we're dealing with code and computational work. So version control is really important, and what I'd like to do today is sort of give a beginner to intermediate sort of level talk on some different version control systems. I'm not a Git expert. Git is a fabulous piece of technology, which is really, really intricate. It's really, it can do a lot, and it's pretty complex once you get down to the internals. I'd say I'm a Git user and practitioner, but I'm not an expert in low level Git. So I'm gonna share my practices around how I am productive with Git and go through some of the basic commands and the ones I use the most and how and when I use them. So basically, that's what I want to get out of this talk, is to be able to share my practices. Take time to look closer as well, because when we're dealing with things like Git and version control and stuff like that, we're usually busy with another piece of work, and we're just dipping in to find out just what I need to do in order to do this next thing so I can get on with my project. And we often don't have the time to step back and play, and look closer and maybe build up some concepts and insights. So that's what I'd really like us to get out of the talk today, to be able to spend some time playing with Git a bit more freely, and to gain some insights into what's actually happening and how to use it a bit better. So, contents. We're going to be talking lots about Git, but not all of Git. We're not only going to be talking about Git, but plus Git is huge, so I'm going to be missing out lots of stuff. But there's some great reference material out there, and hopefully I'll give you enough stuff to be be productive and learn something. We're also going to have a look at curvenote, which is specifically for versioning Jupyter notebooks. Because Jupyter notebooks are particularly challenging with Git, often because we're dealing with something very different from a plain text or plain source code file. We're dealing with stuff with binary and sort of lumps of data in it. And we're also going to look at data versioning, because data versioning is a very important part of the reproducibility workflow. That reproducibility workflow that we're all aiming to reach one day. And data versioning tools can make a big difference there. And one tool in particular, which I learned about recently and is called DVC. So we're going to take a look at that. Now, when I set out to make this talk, I really wondered what sort of questions people had. So I posted a Slido Q&A and got some responses there. And I guess I've based some of the content around Git on the responses I got there, which was a mix of, I guess, basic how do I do X things with Git, and also a bit on best practices about how should I organize things when I'm working alone or working with a team. So hopefully I'm going to touch on both those things. I just want to highlight this resource as well. This is the Git Book. It's fully published online. It's a Creative Commons license, and this is an excellent go-to. This is my favorite resource to head to when I want to look up a Git command or a reference. But the actual, as well as being a reference manual, the actual book itself is brilliant to actually just step through. And if you ever get time, I recommend going to some of the later advanced sections and maybe take a couple of hours just playing through that in order to get a good view of some of the Git internals and maybe build up insights a bit further. I've taken some stuff out of that book into these slides to go through today, but actually going through the way the book does it is a good next step too. Okay, so I published some setup in the Git channel. Sorry, in the channel on Swung, we have our T21 Thursday source control cant channel, which I will keep an eye on. And I published some prerequisites. If you want to play along and try and keep up with the tutorial as we go, feel free. Obviously, there's a lot of typing. This isn't like some tutorials where we can just go through and run a notebook. So it might be a bit much to follow the video and to type the Git commands and everything. But remember, you can always pause the video or come back later and replay bits of it. But hopefully that you've got some of the prerequisites set up, which was Git and VS Code are the two main things we're going to be looking at. Git, I'm on version 2.13, which I don't know if is the latest or not. And then the Git Graph extension I already have installed in VS Studio Code. Hopefully you have too. I've got VS Studio Code open here. You can install extensions just by coming in here, searching the Git Graph, and then you would click install here and probably have to restart Visual Studio. So take a second to do that for sure if you haven't already done it. We're going to be using a GitHub account, so hopefully you're already set up on GitHub. If you're not, sign up for an account either now or later on when you're going to go through this tutorial on your machine, and configure an SSH key. It can be a little bit awkward if you're not used to SSH, but once you've got that set up once on your computer, Git is going to work. It's going to be so much easier just to work with your Git projects once you have SSH configured. Another thing we're going to play with, or I'm going to play with, is the generating text. I didn't want to work with real code during the tutorial because real code, I think, would distract just from the simplicity of what we're trying to do. So when we want to focus on Git, so I'll be using this sort of thing, which just generates random lorem ipsum sentences so that we can get some changes going in some files. So that's all that does, and that's nothing fancy. That's just the same as typing some text. I'm also going to have a working area set up, and I have that on my local machine. So I basically just have an empty T21 folder. Happens to have a data folder in, which I'll use later. But I've just got an empty T21 folder in there, which I'm going to create folders, clone repos into, and to do various things. So hopefully you've got a folder in your machine set up for that. I am on Mac, and I'm a Mac and Linux user. I'm not a Windows user. I haven't used Windows for years, so I haven't been able to give any resources for Windows users. But hopefully if you set up with Git, you have some type of local bash prompt, you'll be able to follow along in the same way. Now I've gone and I have various links to some GitHub repos I've set up to play with. I've posted those all to the Slack channel, and they are in the pinned items, so you should be able to get to those at any point. Great. So that's that. We're also going to be looking at two other things, which I shared in the prerequisites channel. Sorry, in the prerequisites blog post, and I haven't actually moved into my channel. Sorry, my presentation. And that is curvenote. I'm going to be looking at curvenote for versioning Jupyter notebooks in particular. And there's some instructions there on how to sign up for a curvenote account and get the Chrome extension, which allows you to do the versioning. And then we're also going to be looking at DVC, which you can download directly from the DVC site using their installer there. You can also bring it in by pip, but when you install it this method, you definitely get all of the different plugins and extensions. So that's quite easy. And that's what I've done today. Or that's what I've done in order to set up for today. I have the full package installed. Great. Okay. So let's get started. So what's a common use case? I mean, a common use case for Git as a starting point, as a scientist, is you want to take advantage of somebody else's work. You want to get a hold of somebody else's code and use it. You want to get a hold of somebody else's code and potentially modify it, improve it, contribute it, and give it back. So the starting point for all of us are usually cloning somebody else's repo. So in order just to introduce some Git basics and VS Code, I was going to start by cloning somebody else's repository. So let's go and find some. So we've got the Software Underground Awesome Open Geoscience page here on GitHub. So I was going to pick something out of here, for example, Welly. I'm going to copy the SSH URL for the repository. And then that's going to clone me a copy of the entire repository into my local machine. Which is quite large. I didn't realize it was so big. Here we go. And then that's given me not just the latest files that I can see here, but of course the whole repository, the whole history of the project. And now after I've done that, I can see my folder there. And I can go into Welly. Great, so I've just used Git on the command line, Git clone, to check out somebody else's code. And now I have that code available on GitHub. Sorry, on my local machine. So then we can have a look around. So we can go in and we can LSL, and we can see the contents of Welly. And this area is the directory and the set of directories that we've just checked out called the working tree. or our working folders. And I can see all the latest versions of the files on the main branch in there. Yeah. And I can have a look at what other branches were available in the project. I can see actually in Welly, I only have master locally. I can do a git branch all, and I can see that actually I only have master here, but there's a whole other bunch. I can maybe do a git fetch. And now I can do a git checkout of any of these branches, which are actually in the repository, but I don't have the files for that. So I could git checkout develop. I would set up, and now I'm on the develop branch. So git branch is a way to have a look at which branches are available in the repository, both locally, that I pulled down to my local machine, and remotely up on the repo. I can also see what's happened recently in the repo by saying git log, and then we can see what all the latest commits are by Matt. And we can see all these different commit messages that he's put in to mark what happened in each commit. We can go a step further and type a wildly sort of complex command on git log to generate an ASCII art graph of what that actual local history is. So when you check out the GitHub repository, you don't just get the current files, you get the entire history of the repository, and you get all the versions, you get the whole thing. And when you're faced with the command line, you're then in this world where it's difficult to explore and understand really what you've got. And you have to go into and actually learn a lot of commands just in order to explore what's there. And that's pretty daunting for anybody. And I guess very daunting for a scientist who's coming at this without a sort of software background, and who isn't that maybe comfortable on the command line. So that's why I think it's really important to look at Visual Studio Code and some tools to help you, for example. The first thing is that I use all the time is get a prettier command line can help. So I use something called bash Git Prompt, which goes and installs on Mac. There are various Git prompts out there, but this does lovely little things, just like reminds you which branch you're on. It tells you if you're up to date or have local changes. And it can just help you remember where you are and stuff when you're on the command line. But really, I think you should be using and looking at a visual tool to help you understand and help you work with Git. Personally, I move between a GUI-based tool, which is VS Code for me, and the command line interchangeably, depending what I'm doing at any one point in time. Sometimes I'm more comfortable on the command line, and sometimes I'd rather do things point and click in in VS Code. So now if we look in VS Code here, and I've got this little icon here, which is actually my Git Graph. So if I refresh, yes, okay, so this is my Git Graph extension, which gives me this panel. I don't have any changes, so it's not telling me there's any, but we've got this little button up here. If I press that, I now get this lovely view of the entire Git history of Welly with all the branches and everything just there easily. So I can easily come in, I can look at, well, actually, let me just put that back there and maximize my window for a minute. I can go in and I can look at in lots of detail for a given commit, what the details are, what that message is, what the entire file change set was in terms of files. And I can also click on any of those files, and Notebook wasn't the right one. Steve, no, sorry. I can click on any of those files. Yeah, let me click away. I think I've just slowed things down. Yeah, sorry. Oops. This is me clicking around too fast on a slow computer that's running lots of things. I can click on any of those files and get an immediate diff view. And I can just do all these things and be much more productive on the by working through the visual tool. You can get this level of detail on the command line, but you have to learn a lot of commands and be really comfortable with them before you're able just to go ahead and do that. So when I work, I always work with a VS Code graph view in front of me, and with the command line for certain things. For example, the thing I type 200 times a day definitely is git status on the command line, just to sanity check where I am. Cool. So that was like a bit of an initial jump in, because I really just wanted to show you the command line and how difficult that is really to deal with on its own, and also VS Code, and just get us a little bit oriented. And what I'm going to do next is back up a bit and take things a bit more slowly in terms of what's actually happening with Git. And I'm going to use this graph view and the command line to help us track what's going on. Cool. If you have any questions, drop them in. I know there is a lag, and I might not answer them straight away, but I will come back to them. So, right. So this is to the questions I had on the Slido. And basically, is there a benefit using the desktop client? I think I've answered that, yes. Use both side by side is what I do. And the best one's VS Code, in my opinion. But opinions, other people have different opinions. And the minimum you need to know to use Git alone, well, that's really depending on what you're doing. Right now, you've got to the point where you can get a hold of somebody else's code and you can read it, and you can go in and look at it locally and make modifications. You can't contribute back yet, but to actually use Git alone, Git clone, and figuring out which branch is where you need to be are the two main things. Cool. Great. So theory, we're going to talk a little bit about how Git works. So first surprising thing is Git is actually a database. And if you get a chance to go through this Git internals section of the Git book, I know Martin says already he finds this difficult to parse, and the reference manual is difficult to parse. But if you find the time, an hour or so, to go through this step by step, you're going to learn a whole bunch of things that might help you with the concepts. I'm going to go through some of them now. So Git is fundamentally a database, yeah, a key value store. And one of the things it stores is trees. And of course, storing trees is very important, because a tree is a way to point at a directory structure. So Git is able to take snapshots of your working directory at different points in time, store the files within it as blobs in itself, and build trees to represent what's happened with those files. It then builds up different. It gives you version control by having a second thing called a commit. And basically, you have this line of commits, each of which points to a tree, which points to a snapshot of your files. And Git's clever enough to maintain all the pointers to the different versions of the files as it goes, and do all this clever stuff, so that only really ever it's only really ever the changes that are going into the repository. And this is what we usually see, our queue of commits. And then behind the scenes, Git's managing these trees for us. Now, these commits themselves are identified by these hashes. So around Git all the time, we see these large SHA hashes and the shortened sort of 6-character versions of those. And that's not really a nice way to deal with the different versions. We'd like something better. We'd like names, basically, to be able to point to those. And Git calls those names internally refs. So Git maintains a series of refs, one of which are tags, which we can make a tag at any point in time and get it to point to a commit. But Git's branches are basically names which point to commits, like so. So when we're on our main branch, this is out of date, so this is master. When we're on our main branch, the idea of our main branch is a name which points to a particular commit. Branches are a bit special because those names move with us. And there's also another special name called head that we can talk about. A head is a special name which always points to the top of our current branch, generally. Or no, sorry, let's wind that back up. Head is always where our working directory is, so where our current code is. And generally that is also at the point of the same name as the branch, the URL. Now, branches, like I said, are special names. Because a branch is marked by a name, like so, which will move along as we continue committing. So what that lets us do is it lets us split code out in 2 different versions in different branches, so that we can start from a similar root commit and make changes in one direction and make changes in the other. Each of those identified by a name called which is the branch tag. Yeah, and that means we've got diverging histories, and that means at some point, if we want to bring those back together, we have to merge them back in. But that's okay, and we're going to go and look through how that works a bit in a minute. If I was to come in and check out my repository and check it out on the master branch or main branch, which is the default, my head would automatically be pointing to there. Yeah. And when I make a new commit, the new commit will automatically come in and be added to wherever my head is pointing. So that's the special thing about head. It always points to the place at which I'm going to add my next commit. Cool. Cool. Now, this is really getting... there's not much more theory, don't worry. But I added this one because this is a common message that flounders a lot of people. As in, you'll do something in Git, and all of a sudden Git's telling you that you're in a detached head state, which is probably one of the most worrying things you could be presented with as a Git user, or as somebody learning Git. And basically, all that means is you've done something so that your head pointer, as in the code that you have currently checked out, no longer points to a branch name. The head no longer lines up with one of these red things. Instead, it's pointing to something else. And you might have done that on purpose, and that is fine, because you might want to actually get to that commit itself. But Git warns you, because this can mean Git doesn't know exactly where to put the next commit, because it can't. If you add commits to your head here, you don't have a branch to identify it. So I just wanted to point out what this detached head message was, and that it's not necessarily something to worry about. You can get back out of that state just by checking out a branch. And you haven't lost any work. So the next thing is trees. So when you're working with Git, you are working with 3 different things. You have your working directory, which is your state on disk, and whatever files that you have in your directory, that's your working directory. That's what you have currently checked out. It's whatever modifications you have. Git then maintains a staging area, and every time you type a command called git add, you add things in that staging area. So you add changes in. And then whenever you do something called git commit, what you do is commit generates its snapshot based on what's in the staging area, creates a commit, and puts that into the repository as a new version. And we'll see that in action in a minute. And Git talks about staging area as you're using it. So I just wanted to bring that up. The other thing I want to mention is Git itself is a distributed version control system. What that means is there is never, ever really a central repository. All repositories are just repositories, and it's up to you to decide if one's more important than the other. So really, a Git repository is just a version of So a Git repository like the one on GitHub, for example, is just in exactly the same version of the repository that you've got. It's just on somebody else's computer. Somebody who's running a server and makes it easy for you to point to and access that repo. But otherwise, there's nothing special about it. It's the same repo as you have and gets distributed in that way rather than being centralized. So the other thing that GitHub does that is special about GitHub, it's not necessarily Git, or this isn't a Git feature, is because GitHub is a service that helps you organize Git repositories, they add some extra features. And we're going to be looking at these in a little bit. But when they talk about forks and pull requests, these aren't anything to do with Git. These are specifically GitHub features that they have added to make working with GitHub repositories easier. So these are GitHub concepts, yeah? And a fork really is just a copy of your repository. GitHub keeps track of what's forked from what. And then a pull request is just GitHub's way to help you manage moving code from one copy from one repository back to the other with some really good review mechanisms, and they have lovely UI set up in order to help you do that. But those are really GitHub concepts. And that, of course, is no longer not just GitHub, it's also GitLab, it's also Atlassian Bitbucket are using the same language, but really that's about those services. Cool. So hope that wasn't too heavy. I'm going to do some more practical stuff now to let you see what's going on. Right, so let's go back to our command line. I'm going to go back a level, and I'm just going to get rid of Welly. Which is the great thing about having repos on GitHub is that we can just delete stuff and we haven't lost it. We have our backup. And what I'm going to do is I'm just going to create a directory, make the repo, repo 1. Repo 1. Okay. And then I'm in there. And if I look in there, it's empty. Or it looks empty, in any case. if I do ls minus LA and actually ask for hidden files, sorry, dear me, I'm getting ahead of myself. I've created let me back up. I've created a repo that I've created a directory where I want to store some source code and I want to create a repo. So it's completely empty. So one of the first things I'm doing when I'm going to start using Git is I'm going to type git config. It's not away forever, Martin. No. Don't worry, I can get it back at any time. And now Git has a config system, yeah? And basically that's your whole configuration. You can configure Git on 2 different levels. I can configure it globally for just everything on my computer. Yeah, and if I list all the things in my config, there's various things that I've set up. And one important thing is your email and your username. Yeah, if you don't have those set and you try and commit, Git will shout at you. So that's a good thing to set up early on. So I can just git config global, and I'm going to set my name properly. I have to do it in quotes probably. Steve Purves. Global user name. Steve Purves. Yeah, cool. And now if I list again, I've just corrected it and put my full name in there. So you can go in, you can set up different things. Git will shout at you. Like I say, if you're trying to commit without a username set. So now I've got some config. I can call something. I can now call git init. Let me just clear my terminal. Git init. And that's now initialized my repository. If I wanted to now, I could do git config again here locally and set my username, password, etc. Sorry, username, email, etc. on a per repository basis. But I don't want to. I don't need to do that. So what has Git actually done? If I do an ls -a, you can see it's added a hidden directory. And this is where all the magic happens. Git in this hidden directory keeps a hold of everything it needs to track your work. The whole repository is stored in here in terms of objects. All the references to every commit ever made are stored in here, and other things in order to keep track of the repository. And also things that you can customize like hooks, which we're not going to talk about. But there's a lot of things in that Git directory. So now if I just do git status, for example, Git knows that I'm in a directory and that I'm on the master branch, yeah, and that there's nothing being committed yet. If I want to get rid of my Git directory, Git repository at any time, I just remove the Git folder, and that's it. It's no longer a Git directory. So this was one of the questions: how do I tell Git to forget that this is a repo? Do that. So I'm just going to do git init again. And I'm actually going to quickly, sorry, this is a bit out of sequence. So we'll come back to that. You can add Git aliases, basically. So you can use the config to customize Git and add commands like that huge ugly graph command earlier. That's in the presentation. I'll not look at that right now. Okay. So first thing we're going to do is we're going to get rid of master. We're going to rename our branch master to main. It's because I don't have a commit yet. Okay. So let me just actually put a file in this repo. So now I've added a file, git status. Git doesn't know about that file yet. It knows it's there because it can see it in its working folder, but it's untracked. If I type git add, and I git status again, Git's now telling me that there are changes to be committed. It's in the staging area. And it's telling me, oh, if you didn't mean to stage that, here's the command that you can use to unstage. Yeah? But I do want to get that in. I want to git commit with a message. Just say first commit. I've got a message that that was successful. And if I click git status, I'm on branch master with nothing to commit. My working tree is clean. Great. I can now go up to my Git Graph extension, and it'll tell me there's my first commit with master, with file text 1. Brilliant. Now, now I should be able to definitely change my branch. Yes, good. I wonder why I couldn't do that with it empty. I'm sure I've done it with it empty before, but never mind. Okay, so there, we've made the first commit. Yeah? And once we're in this state, like I've already shown, I think, there's a whole bunch of things we can do on the command line, like git log, getting the graph, and git diff. But I would say stick with the VS Code editor, because there you can do everything that you want, including git and diff. I don't remember the last time I actually used diff on the command line. Although I do use a log of it. If I do git log, I will get a log of the first commit. And git log has a bunch of commands, so I can ask it for help and get probably too much information. But, stick using the graph. Cool. So let's do a few more commits. What I'm going to do is just, I'm going to keep ending stuff to my file. Now I'm calling git commit here, and it's telling me the file's not staged for commit because I didn't add it. So every time I have to press add and then change it there. And then we'll see that my Git graph should update. Yeah, okay, just a bit slow. It should update there. I can go and add another line, and all this is doing, if I go and look at my actual file, here, we're just adding lines, a random thing to my file, and I should be able to go and commit again. And I get that message again because I didn't add, but all you have to do is put an AM option in there, and then it will automatically add for you. So there now we're starting to build up some commits, like so. We're changing our code, etc. And of course, this could be multiple files. We could make a folder with lib, and we could put a file in lib. We do git status. It's telling us now that there's some things not added, including this lib folder, which it hasn't even looked in yet. But if I do a git add, and then git commit, then we're all set. And now on Git 5, we've added these two files into the repo. So great. So what Git's doing at each time, at each commit, it's actually building a ref for us. So git show refs, shows the current ref there. That is the ref to the tip of our branch and the last commit that it's shown. I think we can do git all. No, okay, no, that's fine. That's showing the ref to our only named commit, which is this one at the top. Yeah. Now, at any point in time, I can go and add a tag. So imagine if this is very important to me, this particular commit, I can do git tag b1.0. That will now add a tag to my commit. And then let's say if I do some more work, some more work in that file, make another commit, then my tag will always stay on version 5. And when I do git show ref, it's going to show me my name tag pointing to one commit and that there. So tags are useful for marking versions or particular commits that you might want to get back to easily. Cool. So we're starting to progress our repo, adding changes, building up a history on main. What we want to do now is we want to actually leave main alone and go off and do some work on a side branch for whatever reason. Yeah, and we do that via git branch. So we do that by creating a branch. If I just actually type git branch, which is maybe the thing that you actually go to start with, that's not the command that you want. That will just list the branches available in your repository. What we want to do is actually do a git checkout. Yeah. Tell it to create a new branch with the -b flag and say branch A. At that point, we have created a new branch. But if you remember back from my earlier slide, a branch just really starts with a ref, a name, pointing to a particular commit. So we have our latest commit, number 6 here, and we have now 2 pointers to it. If I do git show ref, we can see both these branch names point to the same commit. That's fine. But I've checked out branch A, which my little helper is talking to me. So that's the branch where my head is pointed to. And that is the branch where new commits will be added. So now let's go and add some there. So let's continue to be additive. And I'll add a file. So add some more content. This file's getting longer. I'm going to add another one. Great. So now we come back to our git branch, and then we have this. There's our main. Oops, our main is still pointing to that version, and this new branch has gone and raised ahead. And there's now a few commits ahead. So imagine I'm working on that branch and busy developing a new feature or whatever, and then somebody actually else is working back on main. Or maybe I switch back on main to fix a typo in my README or something. I can do check out main. Now switch back to that branch. It's helping me see that in bold there. I'm going to commit to a different file to keep the example nice and easy. I'm going to commit in 10. And now what's happened is we have this divergent history. Yeah. So this is my commit here, which is what I've currently checked out. That's where my head's pointing. I'm on main, and I've just created that. And now, imagine I want to bring my work from branch A back into main. Yeah, and we do that by doing a merge. And that's pretty easy to do. If I clear my console, what you want to do is make sure that there's multiple ways to do it. The easiest way is to check out the branch that you want to merge into, which I'm already on main here. Then git merge branch A. That is going to create a new commit, which is the result of Git merging in the changes on those two branches. And I can just, I think this is actually opening Vim to do the message. So I just say save please and quit. And now Git's gone ahead, done some clever stuff and figured out what the result of those two changes are and merged the files. So now we are back in and have back into main, and we have the versions of files, the version of the changes from all those files. It was just file 1 is showing from both of those branches. And if I click on here, I can see now a diff, which was the difference between the two, the difference before and after the merge from the point of view of main. And we can see that another 3 changes came in from my other branch. Cool. So that's the basic thing. When you are working in Git, you create a branch, you go out, then these two things can be modified separately, but at some point you want to be integrated and bring them back in. And this is the simplest case and the happy path to that. Conflicts, but things aren't always that simple. So what often happens is Git can't reconcile these two branches. Yeah, there are changes to the same lines and the same files in the code, and now Git doesn't know what to do. It needs you to step in to figure out what to do. So let's just go and set up to look at that situation. So I'm going to have a look at file 1. Yeah. And what I've done there is I've just, I believe, oops, where am I? I'm going to go back to here. I'm going to open file 1, which has now got lots of stuff in, too much stuff. I'm actually just going to overwrite that with 1 paragraph and make that a bit simpler for us. Okay, commit A. Git commit A and A. Right. So let's go back. Right, so now we've got this fresh file just with a couple of lines in here. And now I'm going to create a branch again. A branch. I always branch from the command line. You can do it up here. Can you? No, you can't. Okay. But I always do it from the command line anyway. Git checkout -b, branch B. Cool. Switch to branch B. And there it goes there. And now we're going to make some commits. This time I'm just going to first just add a couple of lines to file 1. Now, this change wouldn't actually make any differences. This would not create conflicts because we just added files. Git knows how to resolve that. Let me put that in. But what happens now if I come in here and change this line, an existing line, and save that? as C. Right, now we have main, and we have 2 commits on our branch. And now it's to see what happens with the merge. Main again. Great, switch back there, you can see. And now I'm going to, actually, let me just make a commit to make this look better in the graph. And commit here. Yeah, right, now we can see obviously our branch is out. We want to bring that back in to D, and we should get a conflict when we do this. Git merge. Branch. Yay, we can't automatically merge. Yeah, so Git helps us here. All of your changes that you go through, it'll list out which files had conflicts. And now you're in this like limbo state where you can't actually go forward unless you either abort your merge, and I think you can do git merge abort. Yeah, you can. And that just backs you out of everything. Or you go forward and deal with your conflicts. Yeah. So let's go in and have a look. And there's various things helping us here. Let's focus first just on what Git's doing. What Git does when it finds out something that it can't reconcile is it will add this sort of meta syntax to your file. It will show you the version on your current branch and the version on the incoming branch. And it's asking you basically, okay, you choose please how to reconcile this because I don't know how to. And what you've got to do at this point is you've got to either accept the top, accept the bottom, or figure out what the right merge of these two things are manually. Yeah. And obviously in the text editor, you can do that on the Git on the command line by following these messages, looking at each file and fixing that commit. The Git Graph plugin really helps us in terms of it flags these merge changes as special things with a little exclamation mark here to tell you what's wrong. So you can actually go to this section to find the files that have the merge issues. You can come in here and you can actually just say, well, accept my current change, stay what, yeah. Anyway, it gives you a bunch of options. You can accept current to get the main change. You can accept the incoming, saying that's better, take that one. You can accept both, or you can just edit the file, wipe all that, and create the right merged version. In this case, I'm just going to accept the coming change, which will take that one. And now, to get out of the limbo state, we need to actually create the merge commit. And if I go and try and do that now, it's going to shout at me. It's not possible because you haven't fixed your unmerged files, but you did fix the files and saved them. Sorry. So what's going on? It's because you have to mark the file as resolved before you can make a commit. So you actually have to go to git add file 1. Actually, VS Code helps you. You could press this button up here to do exactly that. And once you do, you're in a good state and you can commit. Great. So, I mean, merge conflicts are sometimes things that really, well, they can be really scary. This is a really simple case, but if you have merge conflicts, that can really, as a beginner, really put you off. And often what you want to do is really get help, especially unless it's something where you know what's actually happening with the code on both branches. You should be very careful about merging, because you saw there, I can go and accept old code or new code in their own right, and you might accept the wrong one. Maybe neither are right, and you have to craft a manual merge. So you have to be very careful about how you deal with them from the code point of view. But provided that you have knowledge of both change sets, you can usually resolve that. And then it's just about using git add to mark it as resolved and then completing the merge. So it isn't that scary. It's about doing it right, is more about knowing what the code changes were. Cool. And back to this question of what's the minimum I need to know to use Git alone? I think it's this. I think once you've got to this stage, you can now use Git as your version control tool over your project. And you can use version control and have the confidence that at any point in time you can step back to any version of your code. Yeah. Cool. Right. I'm going to take a break, I think, just for 5 minutes. Actually, no, sorry, let's not do that, Martin. I'm just going to spend another 5 minutes going through these commands quite quickly, because then we'll be switching context a bit, I think. Okay, so let's have a look at these quickly. I'm going to change the order up here and talk about git reset and git revert quickly. So we've got the Git Graph plugin up here, and this I tend to use this when I need to do that. If I've got a tree in front of me, I will use the extension to go and check out branches. I will go and check out a particular branch here on the menu. I'll go back and check out. Oh, let me check out commit. Where? I will check out a particular commit, for example, which will get me in detached head state. It's bold there, you can see where we are. If I do a git status, I'm in my detached head state. But I can actually come up back there. But what happens if you want to actually do a reset? Reset or undo changes that I've done. So reset, very briefly, is the way to do that. So let's make some more local changes. And I'll just commit them here, R1, just to get a clean commit. It's AM-R1, right. So there's a couple of different things. Let's say I make some local changes. And obviously I've done it in one file. It's quite easy to see this, but imagine you've got a whole bunch of local changes and I just want to get rid of them. I want to throw these local changes away. I would say git reset hard, which means get rid of my local copies on disk and go back to the head. So go back to the tip of the branch that I'm on. Reset hard head. And what that will do is that will just get rid of those local changes and get me back to where I was. Yeah. Now imagine that I don't want that commit anymore. Imagine I want to just throw away the last commit. I can just do reset there and do git head -1. And now I've moved back and got rid of that commit. Now what's quite interesting is when you do that, you haven't got rid of that commit. That commit is still living in the GitHub repository. It's not attached to any branch yet. It's impossible to see it. If you ever get into the situation where you've done that and you've lost a commit via a reset, it is possible to get your work back. And I would grab somebody who's good at Git at that point and figure out how to get it back onto your branch. A lot of the time, I use git hard, git reset, git hard. So we get reset head or get reset head -1 or -2. I use that quite often. without an issue. That's the way to clear out local changes. Git revert is something very different. And I think as a beginner, you're not going to be using git revert that much. What git revert does is you can point it to a given commit back in the history, and it will generate a completely new commit designed to reverse those code changes. And that is a very advanced thing. And it's advanced because you have to make sure that that commit that you're reversing was atomic and a standalone change set. Yeah, that by taking that commit out, everything still works. So as a beginner or an intermediate even, I would hardly ever go to revert. Revert is usually not the command you want. It's usually reset. Cool. I just want to quickly say something about the stash. So git stash. Git stash is basically a stack. It allows us to have a separate repository, a separate type stack that I can push changes onto. It works like Git in terms of you're getting snapshots of trees and commit-like things on that stash, but it allows you to just get changes out of the way. So let's make some local repo changes. Again, so now I've got some uncommitted changes in my repo because I've added some lines to this file. And now let's imagine I want to get rid of those changes temporarily. And that's maybe because I'm not sure about them and I want to go and save them somewhere. Or a lot of the time it's because I'm doing a git pull to fetch somebody else's code and my changes are in the way. Git tells me you can't do that. You've got uncommitted local changes. So what you would do is just do git commit stash. That gets rid of my uncommitted changes, but I haven't lost them. I can at any point do a git stash list. I can see all my stashes. And if I want to get my changes back, I just do git stash pop. Pop. And then I get my unmodified changes back. So very common, you might stash some local changes, do a git pull, and then pop the changes back off the stash in order to keep going. You may get conflicts doing that. If your stash changes conflict with changes that have just come in, and you resolve them in exactly the same way. You can also use the stash, and I'm not going to go into too much detail now, but you can also use the stash and create named stashes. So I can do git stash, what's the syntax? Push, because it's pop and push, minus m with a message, and just say my stuff. I don't know, that's not really good name, but yeah. And now when I look at the list, you've got my stuff. And then you can maybe refer back to that later. So imagine if you're experimenting with different stuff, you don't want to quite open up a branch for it. You can create you can stick it in the stash. I don't use that much. I'm typically using these top bits whenever I'm using things. Rebase. So rebase is a bit of an advanced concept. I just want to show it very quickly though, because merge is not the only way to deal with things. If I set ourselves up for another commit to main, commit, actually, just quicker, look. If I go up here, commit, add, and say RB for rebase. There we go. Now I'm going to reset back here. I'm going to do a git reset because we just looked at that. And I'm going to go, let's just, no. Yeah, I'm going to do git checkout here. So I'm going back up one. I'm going to do a git checkout minus B for a new branch. Sweet. Yeah, and let's make some new commits on that branch. We don't want conflicts. So I'm going to RB1. Let's do a couple of commits. Now, add RB2. Cool. And what I'm going to do now is I'm going to check out main. Cool. So now we're back in this situation where before we've got a branch with changes and the main's moved ahead as well. What I'm going to do now is instead of merging and creating this branch thing, I want to update. I want to stay on my branch. Yeah. I don't want to merge my branch changes in yet, but I want to get the latest changes off main that somebody else has just done. Yeah. So what I want to do in order to do that is I want to do something called rebase. So I want to check out my branch that I'm on, and I want to type git rebase main. And what this is going to do, it's going to pick up my branch off of main, and then it's going to replay one by one my merge commits on the top of main. So when I do this, we had a conflict. Let me resolve the conflict, and it doesn't really matter. I'm going to just accept the incoming change. So we do have to have a merge, add, merge. Oh, that wasn't a very good example, sorry. Git rebase. Continue. So, git add dot. Okay, I messed that up. I'm going to stop there and take a break, actually, and we will maybe try that again afterwards. Martin, you could do the honors if you're around. Great. So I will be back in exactly 5 minutes. Thank you.
Welcome back, everybody. So handing over to Steve again.
Great, thank you. Yeah, so great. It's always good when things go to plan. I think what I'm going to do is I had quite a lot remaining in the tutorial, and I don't want to overrun, and I don't want to really rush more than I already am. I think I'm rushing a bit. But so what I'm going to do is I'm just going to go through, see how far we get. I'll probably focus on going through all the GitHub content that I had prepared in the session. And then the two other bits of the talk, which was on curvenote for notebooks and DVC for data versioning on top of Git. What I'll do is I'll actually record another couple of small follow-on videos and publish those ahead of time, like that we finish at the allotted time or a little before. So cool. So I wanted to really show rebase, because I do think that is worth having a look at. We want to rebase onto, put rebase. And rebase is important because, like I say, you don't necessarily want to bring in your branch at any one time, but you do want to be able to update your branch based on somebody else's work. And now you could do a merge the other way around. So you could merge from main into your branch. But a much better flow is to do something called a rebase. So I just want to set up the rebase and then show you how that works. So I've just blown away the last repo instead of trying to get out of that state. So I'm just going to do git init. I'm going to create a file. File 1, git add, git commit, yeah, okay, cool. Oh, so we have our file there with some things in. We have our Git Graph with 1 commit. Great. And let me just add a couple more commits just to make this graph a bit more interesting. Cool. So now we have a repository with some work. Yeah. I'm going to do a git checkout minus B to create my branch. Okay. I'm going to make some changes there. Add a couple of commits. Yeah. And so I've been working on my branch, adding code, making changes, doing something experimental off to one side. Meanwhile, somebody else has maybe been working on main. So go back to check out main. Sorry, I didn't rename it master. And somebody there makes a change, additive, hopefully. And now what I want to do is, and makes a commit, G, great. So what I want to do now is how do I get the change from G into my branch here? Well, I could merge. I could go and check out branch A and say git merge main, and that would master, and that would bring master into my branch. But then that would generate another commit, and you end up with all these extra commits picking up changes from your branch. A better way to do it is to say rebase master here from the command line. Or you can do it from here. If you click master on here, you can say rebase the current branch onto branch master. I always do it on the command line. Rebase is something I like to do on the command line because if things go wrong, you need to be on the command line to deal with it. So if I do a git rebase master, I have my conflict again, which is fine. So let's accept the incoming change, which is from D. Fine. Save the file. And I'm going to tell git rebase to continue, because what we've done is we've tried to apply commit D and found there was a merge conflict. So we've resolved that. Sorry, here's where I went wrong before. We've resolved that. We say git add file 1 called text. Now that's staged. And we can say git rebase continue. Oh, Now we have another conflict because when Git tries to replay the next one, we have the same. So we accept incoming change. We can add up here, save. We can add up here instead of typing it. And then we can say Git replay as continue. Accept incoming change again. Save, add, and rebase continue. And finally, we've completed the Git rebase. Now, I do lots of Git rebases, and often I don't have any conflicts at all. Generally because a lot of the changes are in different files. If you have changes in one file like this and multiple commits of those, you do need to resolve the conflicts more often. But what happens at the end is that you have a better history. Your changes on your branch, you're able to pick up and move on to the latest changes of somebody else. And over time, as a repository grows, this makes it much easier to deal with, it gives you a much cleaner history. So rebasing is a good thing to explore and try out, and it'll stop you getting confused with merge commits going in different directions. But it is a bit more work to deal with. So that's maybe definitely an intermediate step. Cool. The last one, which I use lots because I am prone to typos. If I make a change, and if I do a git commit, oops, and I've given it a bad message, I can go back and change my commit message. And I can do that just by doing commit again with the amend option. And then that will amend my commit. Now, what's quite interesting and quite to be aware is you're changing history in a way. You're stepping back and editing data in the last commit. And you just need to always be careful when you change history in Git. Yeah, and actually amend and rebase are both cases where you are changing the Git history. If you're working alone in isolation, that's fine. But if you're sharing your repo, if you're working with others on GitHub, it's going to potentially cause problems, and and it can potentially stop you pushing your changes. We'll see an example of that maybe in a minute. So I'm going to skip over the big dive into VS Code, I think, and continue on looking at GitHub next. But I think a big thing is basically to use the Git Graph extension, explore around at some of the different features it gives you. It allows you to find information out about, jump to a particular version of a file. It allows you to, I'm not on a branch here in this repo. It allows you to view diffs easily, and it's a wonderful tool when you're dealing with a real repository with many files. It really helps you work through your commits. And if you have many changes, this is a great way. This list works lovely, where you can actually pick out group changes and commit files independently using this interface. It's well worth exploring further. Right, so getting my code into GitHub. Let me back up RMF and get rid of that repo. Cool. And now I'm back to the start. Right. So now you have some code. You want to be able to get it into GitHub. One of the things I want to point out here that is often difficult to find when you're out looking at the docs is, remember, Git is distributed. Yeah, and a GitHub repo on GitHub is just another copy of your repo on someone else's computer. So maybe I blew that repo away a little bit too quickly. Make the repo 1, make the repo 2. Repo 1. Let me just do my git init. I probably shouldn't have deleted this one. Let's create a file. Do a git add. Do a git commit. Great. Jump over here. Refresh. Git Graph. Yeah, there's my repo with 1 commit. We just make 2. So put 2 commits in there. Let's back out now and then go to repo 2. Yeah. Now repo 2 isn't a Git repo yet, it's just a folder. But I'm going to make a Git repo. I'm going to say git init bear. And what git init bear does, it creates a repo without a working folder. That is just a repo that just has the .git folder in it. It's a slightly different way to set up. And once you create a repo like that, what you can do is if I go back into repo 1, I should be able to make changes. I should be able now to do a git push to my other repo. So git push, I'm hoping this works because I haven't done this in a while. To repo 2. It's asking me to set my upstream. And of course, name my branch. Cool. So I just did a push, a git push, which you normally associate with GitHub. I've just done a git push up into a different folder. Yeah. And now if I go back here, if I go to repo 2, we get status. Operation must be run on a work tree. Git log. I can see that now in repo 2, I have my 2 commits from repo 1 that I did over there, and I pushed to this repo. So this is exactly what you're doing with GitHub. In GitHub and all these things, all you have is these bare repos up there that you are pushing to as a repository. And GitHub's giving you the service to handle that. If I want to turn this into a fully fledged repository, you would do a git checkout master, I think. No, okay, actually. I'm not sure off the top of my head how to get out of the bare repo state. Interesting. But anyway, that is actually a push to a local file on disk, a local repo on disk, and then you would be able to push and pull from that repo. So if I do a git pull now from this other repo on the file system. Yeah? Cool. So with that in mind, let's go up to GitHub. Yeah? So let's imagine I already have a repo locally like this one. Let's go and do essentially what is git bear on GitHub. So I'm going to go to my GitHub account, create a new repository called repo 1. Nobody is there? Okay, repo 1. Create repository. And then I can create a repository like that. And that's created up this bare repository that doesn't have anything in it on my on GitHub, which I can now push to like I just did in that folder. And this is a fairly common state where you already have a repo locally. If you want to create a repo from scratch on GitHub, you just do it and include a README file, and then you can go and clone it. But a lot of the time, when you're working, you have a repo, you've done some code and you've used Git locally, and you need to push it up there. So when you create your repo, Git gives you some helpful instructions. And what you need to do is just point your local repo to your new remote repo. And Git has some special commands for that. Yeah. And the command is git remote. If you type git remote, doesn't do anything. If you type git remote -v, it's actually going to list the remotes that you have, and I don't have any at the moment. So I'm going to add one. I'm going to do git remote add origin, which is the convention. And look, it's got the whole command there for me. And I'm going to put my GitHub address in there. Now, when I check my remotes, I can see it listed. I'm actually going to add another remote, git remote add local, which is repo 2. That's a fully fledged remote. It just isn't on GitHub. So now that I've done that, I'm going to actually take the opportunity to rename this branch to main. Yeah, great. And now what I'm going to do is I'm going to push. So just like I pushed to my repo, I'm going to now push to GitHub. Now, what's interesting, if I do a git push here, it's probably going to complain. Yeah, it's for start two things. Two things to start with. I did a rename, and it doesn't know which branch to push to on repo 2. Second thing is it's remembered that my local main branch is actually set to point to repo 2, and I don't want that. What I want to do is I want to do a git push -u to say set my default upstream for this branch, origin, main. Cool. And now what that's done is it is pushed to main. So now I can go on GitHub, refresh, and there's my repo with my file in with nonsense text. And now the main branch is set up to track the remote branch main from origin. So now I will always be able to git push. I have no changes at the minute. It's saying everything is up to date, but it's always going to push to origin now. So let's get back to the point where let me modify my file manually. Hello, cool. And it's just to make a git commit here. Hello. Push. So on, and that automatically comes up to here, and we'll see the commit history on GitHub. Hello. Cool. Yeah. So that's pretty much it. When we do a checkout of a branch and create a new branch, things work just the same. So if I do git checkout -b and create my, say, feature branch, which is b1, and do a git push, it's going to say again, I'm confused, I don't know where to push it to. Yeah. And I'm just going to tell it to push to a new branch on origin and to keep my upstream linked. Oh, and then we should see. Now if we go back to repo 1, we have 2 branches. Simple as that. Yeah, so that keeps everything tracked. You've published your work, you've published multiple versions of it. And that's fine. And I've just closed the repository, so let's bring that back up. Great. Cool. The other thing just to bear in mind is if you use tags at any point, there's a special command on your push to make sure the tags get pushed as well. Otherwise, they don't get pushed. And that's sometimes a bit of a trap. So, okay, working with others. So publishing, we've covered. And basically just getting it out on a server somewhere, getting it to GitHub, you've published. And you've just got to be aware of rewriting history. So if you're going to do resets that change the number of commits that are on a branch, if you're going to do commit amends, and definitely if you're going to do rebases, you're going to be rewriting Git history. So one of the best things to do is, if you're a beginner, is just to stay away from these things. In general, until you're comfortable with dealing with them, or do them before you actually make a commit. Do them before you actually do a push. So especially if you've amended your message, etc., before you've done a push, that's fine. Once you push, you've published, and then others could potentially consume it. And if you run any of these commands and then try and do a force push up there, then they're going to cause other people problems. Yeah, so just be aware of rewriting history whenever you're publishing. Yeah. An interesting thing to watch for when you do go down that route is Git, and quite recently, I'm saying recently as in not from the start, added a special option called force with release. This can allow you, after a rebase or a reset or something, if you push with a branch with force with release, it gives some extra protection for people who are using a repository in order to be able to cope with that and not lose any work. So if in doubt, always push with force with release. Right, contributing. So we're going to have a quick look at what the PR workflow is and what maybe a typical workflow is around contributing to someone else's open source repo. Yeah, so this is the setup that we have. We have an original repo that maybe you've found and you want to make a contribution to. The right way to do that in GitHub world would be to create a fork. And from that fork, create a PR that points back to your, that gives the original repo owner a notification and a really nice way to view your changes to decide whether or not to incorporate those. But of course, you can't really do that on GitHub. You need to do that via your own local repository. So in this scenario, there are 3 actual repositories involved in the mix. Now, one way you might enter that situation is, and it's the ideal way, probably, is that you know ahead of time you're going to make some changes in that repo. In which case, you on GitHub make a fork. You clone your fork locally. You then make your changes and stuff and commit, and then you push back to your fork on GitHub. And you open a PR back to the main repo, yeah? And then you do something called configuring an upstream remote, just so you can pull in more changes locally as the main repo evolves. I hardly ever get myself in this situation because often what happens is this, that you've cloned somebody else's repo. For whatever reason, you end up making local changes, yeah, and not really thinking about should I fork or anything, but then you realize you want to contribute those back. And the only way to do that is to then create a fork. And then when you do things that way around, there's a little bit more work about using Git remote that you need to do to set yourself up properly. But once it's set, it's simple, and you can go through the same workflow. So we're just going to use our remaining time, I think, to I guess, step through this workflow locally, because it's the most common one. Yeah. And I've got a repo prepared for that. I'm just going to look at the channel and in here pick up this link, which is this Lorem Ipsum repo I prepared. Cool. So this is just a little repo I prepared. I've got this org called Utility with a couple of repos in it, and I've created it under there because that should let us see this, forking and PR workflow a bit more clear, a bit clearer. So anyway, imagine then that I want to get this code file repo. I will clone the address here. Let's clear my terminal. And let's just do git clone. And I'm going to cd into T21 from Ipsum. Great. Here it is. We're going to Git Graph. It's now recognizing multiple repositories. I'll get the Git Graph on this. And this is very simple. I've just got a couple of commits. Yeah. I created the README. Let's go in and make some changes. So I'm just going to do something obvious. And here are some local changes I want to contribute back. Okay, I'm going to save that locally. And I'm going to git commit my contribution here. Cool. So I'm in this state where I've got a local copy. In my repo, I have made another change. It's telling me, look, my little helper is telling me that main, I'm on main, I've got one commit and one commit ahead of my remote. Now, if there was my repo, and this is, so I'm not going to actually do it, but if there's my repo where I have full admin rights, I would just at this point just do git push to push my changes up there. But in the real situation, you don't have push rights on somebody else's repo, so it won't let you do that. So, and I've already got my changes locally. I really, but I need to create a fork. So what I'm going to do is I'm just going to do git remote -v. And now if I do git remote -v, my origin is pointing to the repo that I checked out, which was the original repo by Utility. And I can't push there because I'm not the owner of that repo. So instead, I go to GitHub and I press fork. And I'm going to fork into my account. And now GitHub starts to tell me this. So GitHub's making now a copy of their repo in my namespace, if you like, and it says that this is forked from there. So GitHub keeps track of that for me, so that they can give you this experience that is. Oops, sorry. So that they can give you this sort of experience that we were talking about. So now we have a fork. My fork has a different address. It's Steve J. Purves instead of Utility. So now what we're going to do is something I do a lot. This is really common. What we're going to do is reconfigure our remotes a bit. Yeah, we definitely need to add a new remote for our fork to be able to push to it. But what I commonly do here is I do a git remote rename origin upstream. Yeah. Upstream is my favorite name for the original repo, the one where eventually we're going to be pushing to and where we're going to want to pull other people's changes from in the future. I then do git remote add origin, a new origin, which is my real origin now, which is the origin of my fork. And now, sorry, if I do a git remote v for verbose, now I can see that I have my two origins set up like that. Yeah. So now I'm able to push to my fork, which I've called origin. So I can definitely do git push -u. Yeah, and let me just pop over here, actually. Go to commits. I can see there's 4 commits. If I do git push u origin main, hopefully. Yes. Now I've just done a push to my fork. If I refresh this page, there it is. There's my push to my fork, my contribution there. Yeah, and that's that. Now my fork is now ahead of the base repo. What I can do then is I can open a pull request. Is this the right way to do it? Will it let me? And I can do it from my repo, I think. Cool. And look, GitHub's sort of sniffed what's going on and has already figured out what the right pull request is. So pull request is a bit like just pending merge. It's like a merge hanging in the air. So we could merge any branch to any branch and any branch to any branch in any repository. And that's what you have here. You're saying, what is the repository you're merging to? Well, we're merging to utility on the main branch, and we're merging from my fork on the main branch. It gives you this nice little preview of here are the incoming changes. And if I create a pull request now, it's just really useful docs. Something you can leave a comment, and well, really on an open source project, you would want to provide a meaningful description of what your changes were and why you were doing them, link issue numbers and all sorts. But basically, you give some description, which you can preview because you can add links and all sorts there. This by default allow edits by maintainers, allowing the maintainers of the other repo to make changes, and you can create a pull request there. Cool. Now, what's actually happened is GitHub sneakily has taken me back to the base repository where this pull request lives. So the pull request doesn't live on my fork, it lives on the base repository. And you would be able to go and see your pull request, but you wouldn't be able to say merge. Yeah. Now, I'm a maintainer of this repo, so I can see merge and then actually merge the request. So this is the experience you will get if somebody makes a pull request against your repo. You'll see on the pull requests page, you'll see a list of pull requests. You enter into each one. You'll be able to see the commits that were made, a summary of all the changes to all the files, and some excellent review capabilities. And you'll be able to, if you're a maintainer of the repo, hit merge pull request, confirm merge, and boom. And so now that change from the forked repo is now included in this repo. Yeah, cool. So what we've done is we've done that. We cloned this repo originally. We made some changes. We decided we want to contribute them back. We created a fork, reconfigured our remotes. We pushed back to our fork and opened a PR, which the maintainer accepted. Yeah. There's only one thing left now, is that these two repos, these two repos are in sync, but this repo now has potentially an extra merge commit. Yeah, it doesn't in this case, but imagine it did. Or this repo over time, for example, moves forward because other people are also committing there, and we want to stay up to date, and we want to keep our fork up to date. what you would do here then is go back to our remotes that we configured. Yeah, and what we would do is we would do a git pull from upstream main, right, which is bringing in, I think, the merge into our local tree. Yeah, see, and so we brought in main from upstream. We got the changes from this repo, and now we have to make sure that our fork is up to date. So we now do a git push to origin main. And now we've completed the circle. So now at that point, all these repositories are now back in sync. Yeah. So it's quite an evolved workflow in a way. You've got to deal with 3 repositories that you're dealing with. But once you get used to this pattern, then it sort of becomes second nature and easy to handle. Yeah. Cool. And that's the typical GitHub way of doing things. The second workflow is definitely closer. Yeah, I agree completely. I always, it's always after the fact, typically. Right. So let me talk about another few minutes then about, I'm not going to go through any more demo, but let me just wind things up with maybe answering some of the other questions that came in on the Slido poll and giving people some places to go look for more information. So, best practices for working on a project owned by somebody else. I think we've just covered that really in the GitHub style anyway. It's basically you want to be doing forks and you want to be opening PRs. Is Git for collaboration or should I just be using it on my own projects too? I'd say use it on your own projects too, definitely. The amount of confidence you get with having version control on your project and knowing that you're able just to step back in time if things go wrong is huge, and it changes the way that you develop. I mean, for example, one thing is if you're using version control and you get used to committing often, there's no need really to leave comments in your code. You know, a common thing is you want to make some changes, but you're not sure, so you'll comment out blocks of code. And once you get confident with version control, you can just stop doing that, because deleting a piece of code in a file doesn't mean it's gone forever, because you can just step back in time to a previous commit. Or if you haven't committed yet, you can just stash your changes. And remember, stash will actually undo that deletion and give you your code back. So you could find that you have a lot less of this commented out code around your code base if you just rely and are confident in your Git version control. When working alone, should we just commit as a go or be more structured? Still, I'd say still try to be structured. I think when you're working on your own, I think really question yourself if you're going to open a branch. Why would you want to ever open a branch? I think you might maintain 2 long-lived branches if I'm working alone, one for development and one just to mark releases. I'll talk about that again in a second. But beyond that, I would say don't branch unless there's a really good reason why you're branching, because of what you're about to do. And then just, commit as you go. Always try and produce atomic commits if you can. So imagine that if you revert any one commit, that gets you back to a working state. That is the thing to strive for, that every commit reflects a working state of your repository. Why is main plus Mr. X branch, Mrs. Y branch not a good practice? That's something that right. These next set of questions I'm going to deal with in the next 2 slides. It's not a good practice. Don't deal with it. These are called long-lived branches. and you spend all your time figuring out how to integrate changes back across. What's a sensible policy when it comes to branches? How many should I be using? As few as possible. How to deal, or none at all if you can. How to deal with others changing a file before you're trying to merge. Minimize your branches. Git doesn't have a staging ground in that way. The best thing you can do is git stash and move things off, but yeah, it doesn't really help you with that. You can get pipped at the post still. And when should I merge my work as often as possible? So the two other things I wanted to talk about quickly is something called Git flow. And for me, you can go up and read about it. There's a blog post linked here, and I'm going to share these slides. But Git flow is a bit over the top for my purposes, but there are a couple of things I really liked about it that changed the way you're thinking. With Git flow, you have two long-lived branches. Yeah, so your main branch is not really where you're working. The idea is you create a separate dev or develop branch, and that is where all the work goes on. And then every time a commit makes it back to the main branch or the master, that commit reflects a release of your code. Yeah, so that's good because then you can walk back through the main or master branch, and you know that these things are always just releases that you could switch to or revert to. Yeah, that's your main publishing branch, if you like. While on develop, that's where you're continuously integrating all your changes going forward in. And when you want to create a release, you're popping off into another branch. Git flow has release branches in, and I'd say avoid that if at all possible. And for small projects, you're not going to need it. That's about stabilizing code during testing while a whole other team of developers are off doing something else. Avoid, if you can, avoid at all costs, I'd say. Feature branches also, either avoid at all costs or make them as short-lived as possible. I'm talking about branches that live a day or 2 days in the project, not longer. And ideally, the shorter you make your branches and avoiding the need for branches other than develop and master are the best. The really good thing about the Git flow model, these two branches, is that hot fixes. You could be off on developing the next great bit of your code, but if somebody wants, if you have a bug in production or a user area library and you want to fix something quick, this model allows you to flip over to main, create a branch for a hot fix, just addressing that one issue and creating a new release quickly without having to think at all of what's happening in your development. So learn a bit about Git flow. It's good, but it is over the top. There's just these couple of aspects that can really help you, though, and they're the ones I use. Yeah, we're out of time, so I'll skip these things here. Other people talked about continuous integration. And continuous integration, you can go off and read about this, and there's lots of different opinions out there. But the key is in the title. It's integration. And if you have people working on branches, and if you have branches in your code that last more than a day, or more than that aren't short-lived, then by definition, it's not integrated. Continuous integration is about your software always being up to date with all changes in it, or as close as possible to that. So some companies and dev teams strive to actually have all developers working on main, but at least they have no long-lived branches and merge as frequently as possible. And then you might say then, well, hold on a second, how do we develop concurrently then? And that's done, instead of relying on the version control system and branches to do that, you rely on your architecture to do that. So you structure your code in such a way that it's modular, that you can switch different features on and off. And actually, some teams go to the extent where code that doesn't work yet is included in the main branch, but it's just inaccessible. It's just switched off, a feature toggle. Nobody can reach it. But the code and its use of dependencies and the refactoring it's caused in the rest of the code base is still present very early and having an impact. And that integration is happening continuously, and that's the point. So branches create extra work. We've seen rebasing, we've seen merging and conflicts. They all cost time and potential for error. So if you want to do continuous integration, you minimize or completely remove your need or reliance on branching. Okay, I'm running over time. I'm going to leave things there. We haven't managed to have a look at versioning for notebooks with curvenote. I will do that in a follow-up video. Basically, Jupyter notebooks and Git have various problems, and curvenote provides you with a different version control that integrates with Git and resolves those problems. Same with data versioning. If we start to try and commit our data files, especially if they're binaries, into Git, we run into size issues. We bloat our code repository, and we get a whole other bunch of problems there. In the same way as curvenote, DVC is a method for versioning your data out on S3, Google Drive. It's lovely to use, and it actually all links in and integrates with Git too. So that's another thing I'll do a quick video on and share after the fact. And that's it. I'm going to leave it there. I'm very sorry for overrunning, and I'm sorry I didn't get through all the content, which I've seriously underestimated the amount of time I would need to do the interactive bit. I'll be around in the channel after this for any questions and stuff, and I hope it's the first time I've given an interactive Git tutorial like this, and I hope that you got something out of it. Thanks.
All right. Thank you very much, Steve. I certainly saw some useful stuff that I had not seen yet. So thank you very much for giving that. If people are watching this live, remember that there are a few other sessions still coming up. There's some geothermal stuff happening later today. There's the lightning talks, which should be starting in just under an hour. Thank you to AWS, thank you to StudioX, thank you to Agile for funding, and the Software Underground for hosting and supporting. And we hope that we will see you again for something soon. This is one of those that I think has been a really useful one, and I hope that people are able to take this forward and start collaborating better, which I think is really what this also allows in a very concrete way. So thank you again, Steve.